Geometry review. If we look at this figure, we can see that we have a start or stop point, and then we also see that it continues on forever and ever in one direction. That tells me that this figure right here is what we call a ray. So we have a ray, but if we wanted to name our ray, we would write QR, since those are the two letters on the ends, and then we would draw a small ray over it to represent ray QR. If we look here, this is probably one of the easiest. We have a point, and it is called point L. What figure is this? That's correct. This is a line segment because it has a start point and it has a stop point. So that makes this a line segment. To represent a line segment, you would draw a small line and put NO. What about this geometric figure? What is this? That's correct. This is a line. To represent this line, we would draw a small line, such as this, and write VU. Now, if we start looking at some more complicated ones, here we have two what? That's correct. We have two lines. Let's go ahead and name our lines. So our first line is going to be line FG, because F and G, okay? What is our second line? That's correct. We have line HI. Now, if we look at these two lines, so this line and then this line, these two lines will never touch each other. That means that these two lines are what? That's correct. They are parallel. When you have two lines that will never ever touch each other, they are parallel. So let's look here. What geometric figures do we see here? That's correct. We see two lines, and if we go ahead and name them, we have line BC, and then we also have line DF. So my first question for you is, are these lines parallel? That's correct. No, they are not. But how do we know they're not parallel? Exactly, because of right here, these two lines intersect, okay? This means they are touching each other, but they do not form a right angle. We can look at the angles that we see right here and then right there, and we see that those angles are going to be acute. So these two lines are what we call, forgot my line segment. So these two lines are what we call intersecting. Alright. If we look here, again we have two sets of lines. We have ST and then we have VU. Okay? Now, notice something about these two lines. They are touching, and when we said two lines touch, that makes them exactly intersecting. But do you see this red square that's right there? That red square stands for something. That's correct. That red square stands for a right angle. So, we know that these two lines are touching to make right angles. So that means that these two lines are perpendicular. Exactly. So we have line ST is perpendicular to line VU. Alright, let's look at this one. So we have line AB and we have line DC. Now, these two lines are not touching each other, but will they ever touch each other if they kept going on and on? So if we extend this line out like this, and then we extend this line out like this, did they eventually touch each other? Yes. So these lines are intersecting. They're intersecting because they touch each other, but did they make a right angle? No, they made an acute angle right there. Okay, what shape do we have here? This is a parallelogram. It is a parallelogram because it has opposite equal sides, and it also has two sets of parallel sides. So we know that a parallelogram has opposite equal sides. It also has two sets of parallel sides. So what we're going to do is we're going to use these arrows that they've already drawn on the shape for us. You see these two arrows right here? Well, what it's showing us is that these two arrows, or this side, is equal to these two arrows, or this side. Meaning that this side and this side are equal, but they are also parallel. So if we look at this single arrow that we have right here, this single arrow is equal or parallel to this one. Now, what shape do I have here? So this is a trapezoid. What are the characteristics of a trapezoid that we know? It is a quadrilateral, meaning it has four sides. It should also have two sides that are possibly equal, but it should have one set of parallel sides, and that's the main one we want to focus on. So with one set of parallel sides, we can see this one arrow and this one arrow. These two sides will never touch each other. No matter how far out they go, they're never going to touch each other. So that makes these parallel sides. Now, if I wanted to, I could also identify some intersecting sides in here. Intersecting are lines that, correct, they touch each other, but they make what kind of angles? That's correct. They make acute or possibly an obtuse angle. So, if I take this line right here, stretch it out in the red, and then I take this line, and I'm going to color it blue now, and stretch it out. These lines right here are what we call intersecting. They're intersecting because you can see we have two acute angles, and then we have two obtuse angles. Okay, what shape is this? This is a rectangle, okay? Now, rectangles, we all know about rectangles. Rectangles have four right angles. Rectangles have opposite equal sides. So this side is equal to this side because they are opposite. And then this side is equal to this side because they are opposite. But I also know that this side and this side are not just equal, but they are also correct. They are also parallel. And then if we go back to this side is equal to this side, but they're not just equal, they are also very good. They are also parallel. So we could say that this rectangle has how many sets of parallel sides? Exactly. It has two sets of parallel sides. Now, to really go back over something real quick, if we think back to the first thing I said about my rectangle was that it had four right angles. Remember that I don't even have to measure these because I see that red box right there. That red box lets me know that I have four right angles. Okay, let's talk about a protractor. So, when we are using a protractor, couple things that are always number one important. This line that is on the bottom of your protractor, this black line right here, okay, always, always, always has to go on that bottom ray of your angle, okay? Then, this dot right here, so this point where the two rays meet, always, always, always has to go on the dot or the point of your protractor. Then, you follow this ray up, unto the number, and we see that it's at 30 and 150. So this means that we have to choose. Well, if I look at this angle that I see here, I can see that I have a what kind of angle? That's correct. This is an acute angle. It's such a cute little angle. Now, if it is acute, that means it is less than 90. Okay, so we know less than 90. So that tells us which number we're going to go with. That's correct. This angle, DEF, is 30 degrees. Let's look at another one. Okay, so again, you always have to make sure that that bottom ray is lined up on that black line. Then you always have to make sure that point is where the point goes. Okay, then we are going to follow our ray up, and we can see that it is on 10 or 170. So again, the next thing we have to do is figure out, is this an acute angle or is this an obtuse angle? Again, it's such a cute little angle, so it's acute. And we know that acute angles are less than, that's correct, 90 degrees. So the measure of this angle is 10 degrees. Okay, what kind of angle is this? That's correct, this is obtuse. We know that obtuse is greater than, that's correct, it is greater than 90 degrees, okay? Now, let's make sure that they lined up our protractor correctly. We take this bottom line and we line it up on our ray just like that, so they did a good job there. We need to make sure that the point is always at the point. They did a good job there. Let's follow this ray up. So if we follow it up, okay, I can see that it is at 40 or 140. So knowing that this is an obtuse angle, that's correct, it's a 140 degree angle. Let's look at one more. Oh, what kind of angle is this? It looks like it could be a right angle. And we know that a right angle is equal to 90 degrees, but let's double check it just to be sure. We take our ray and line it up on that black line of the protractor, so they did a good job there. Then we're going to take our point where the two rays meet, and we're going to make sure that it's on the point of the protractor, just like that. Then we're going to follow this one up, just like that. And I can see that it's at 90. So again, the measure of our angle is 90 degrees. So is it a right angle? Yes, it is. So this has been your geometry review. Now take a look at our picture. Can you find an acute angle in the words geometry or the words review? That's correct. Okay. Here we have an acute angle. We also have an acute angle here. We also have an acute angle here. Can you find a rectangle in the word geometry? Ah, yes we can, because we see that this side is equal to this side, and then this side is equal to this side. And we know that a rectangle, the sides that are equal, are also parallel. So the red is parallel to the red, and then the green is parallel to the green. One more. Do we see any perpendicular lines? Maybe in the word geometry or in the word review? If I were looking for perpendicular lines, I would say that perpendicular would be right here, where the eye meets its base, or right here, where the top of the T meets its base. When you are ready, you may go ahead and start your geometry unit test in Schoology.